Okay, good afternoon, children. So now we can revise the group 16 elements through MCQ questions. Okay, we can start with MCQ questions, then assertion reasoning, then case study based questions. Just 1 minute. Okay. So before that, can you tell me which are the elements present in group 16? Anyone? Group 16. Which family is that?
Oxygen.
Oxygen family. So which are the elements present in this group 16?
Oxygen.
Hmm.
Chlorine.
Oxygen. Oxygen.
Sulfur.
Sulfur.
Tellurium.
Hmm.
Selenium.
Hmm.
Polonium.
Hmm. One more. Livermorium, right? Okay, so these are the elements present in group 16. Okay, so we can discuss the MCQ questions from this portion. Is this clear, children?
Yes.
Is the screen visible? Do you want to zoom it again?
Yes, madam.
Yes means, do you want to zoom it again?
Yes.
Okay. What about now? Clear, right?
Yes,
Okay.
ma'am.
Okay. So 13th question. 13th question. Arrange the following elements in the correct order of increasing ionic radii. Okay. Arrange the following elements in the correct order of increasing ionic radii. So you know that the elements in group 16, selenium, tellurium, polonium, oxygen, sulfur, then livermorium. That is not common. That's why it did not mention here. Okay. So which is the correct order of increasing ionic radii? Increasing ionic radii. What happens to atomic radius or ionic radius in a group from top to bottom? Is it increases or decreases? Atomic radii or ionic radii?
Increases.
Yeah, it increases from top to bottom, right? So what will be the correct order? Option A, B, C, or D? Tell me. Anna?
Ma'am, is it B?
B. Increasing from top to bottom. So oxygen has least, right?
A.
Yeah, option A. Starting from oxygen, then sulfur, selenium, tellurium, polonium. Okay. So option A. Option A. One minute. Shall I move to next question? Okay. Dia, can you read the 14th question?
Water is much less volatile than H2S because option H2O has a bond angle of nearly 150 degree. Hydrogen is loosely bonded with sulfur. Option C, S atom is less electronegative than O atom. Option D, S atom is more electronegative than O atom.
Water is much less volatile than H2S, okay, hydrogen sulfide. Because option A, H2O has a bond angle of nearly 150 degree. Option B, hydrogen is loosely bonded with sulfur. Option C, sulfur atom is less electronegative than oxygen atom. Then option D, sulfur atom is more electronegative than oxygen atom. So what will be the correct answer? Yes. Can you tell me the reason? Anyone? Correct answer. H2O has a bond angle of nearly 150 degree. Then hydrogen is loosely bonded with sulfur. Then sulfur atom is less electronegative than oxygen atom. Sulfur atom is more electronegative than oxygen atom. Which is the correct answer? Yes, tell me.
Sulfur atom is less electronegative than oxygen.
Very good. Sulfur atom is less electronegative than oxygen atom. That's the correct answer. Okay. Because when we are moving from top to bottom, their electronegativity will decreases, right? So the sulfur atom is less electronegative than oxygen atom. And it will not, in the case of sulfur, it will not form hydrogen bonding with the other molecules. In the case of water molecule, there will be hydrogen bonding. So water is much less volatile than H2S. Okay. So in hydrogen bonding, the bonding will be very stronger. So it will take more time to convert into the form of vapors. Volatile means it is converted to the form of vapors, right? So what in water, the hydrogen bonding is there. That is due to the difference in electronegativity between oxygen and hydrogen. Oxygen is more electronegative, hydrogen is less electronegative. Okay, so hydrogen bonding will be there in H2O molecule, but in H2S there will not be any hydrogen bonding, and it is very less electronegative than oxygen atom in the case of sulfur. So option C is the correct answer. Clear? Yeah, Chut. Page number I didn't find out from the textbook. Just wait. Point about this hydrogen bonding in the page number 187. 187, last paragraph, anomalous behavior of oxygen. Okay. I will check that and inform you. Okay.
Okay.
Okay. Now we are moving to next question. Question number 15. Tetrafluorides of elements of group 16 have hybridization and structure respectively are option A, sp3 and trigonal pyramidal, option B, sp3d and tetrahedral, option C, sp3d and trigonal bipyramidal, option D, sp3d and tetrahedral. Tetrafluorides of elements of group 16. Tetrafluorides of elements of group 16. Here the all of you take your textbook, page number 188. Under the heading reactivity towards the halogens, you can see the answer. Among the tetrafluorides, SF4 is a gas starting like this. Here the hybridization and their structure is mentioned. Page number 188. Okay. Navrin, can you tell me the answer?
sp3d and trigonal bipyramidal.
Yeah, sp3d and trigonal bipyramidal. Okay, that means option C, right? Option C. Do you mark this in textbook, children? Page number 188. Second last paragraph. And the next question. On heating ammonium dichromate and barium acetate separately, we get. Actually, this from group 15. Okay. On heating ammonium dichromate and barium acide separately, we get option A, N2 in both cases. Option B, N2 with ammonium dichromate and NO with barium acide. Option C, N2O with ammonium dichromate and N2 with barium acide. Option D, N2O with ammonium dichromate and NO2 with barium acide. That's about the preparation method of dinitrogen. So you can tell me which is the correct answer. The decomposition of ammonium dichromate and barium acid will give
N2.
yeah, N2 in both cases. Option A. Okay, both ammonium dichromate and barium acid on decomposition will give N2.
This is from the last group, right?
Yeah, group 15. Page number 174, their preparation methods. Okay, Aditya, can you read the question number 17?
Yes, ma'am. Rhombic and monoclinic sulfur prepared respectively from roll sulfur in CS2 and rhombic sulfur, monoclinic sulfur and roll sulfur in CS2, monoclinic sulfur and rhombic sulfur, roll sulfur in CS2 and roll sulfur in CS2.
CS2. So here the 17th question, rhombic and monoclinic sulfur prepared respectively from. So the first one about the preparation of rhombic and the second one monoclinic sulfur. Okay. So option A, roll sulfur in CS2 and rhombic sulfur. Option B, monoclinic sulfur and roll sulfur in CS2. Option C, monoclinic sulfur and rhombic sulfur. Option D, roll sulfur in CS2 and roll sulfur in CS2. So here it's from page number 192, preparation of rhombic and monoclinic sulfur. Page number 192. Aditya, can you tell me the answer? Rhombic sulfur from? Rhombic sulfur crystals are found on evaporating the solution.
Roll sulfur.
Yeah, roll sulfur in CS2. Then what about monoclinic sulfur? Yes.
Rhombic sulfur.
Yeah. So which is the correct option? First one, roll sulfur in CS2 and second one is rhombic sulfur. So which one is the correct answer?
Option A.
Yeah, option A. Rhombic sulfur is prepared from roll sulfur in CS2 and monoclinic sulfur from rhombic sulfur. So actually it's like this. Role sulfur will be converted to rhombic, the presence of CS2, then it will be converted to monoclinic. Okay. Then 18th question. Tania, can you read the 18th question?
Which of the following is an isoelectronic pair? Option A, IC2, CiO2. Option B, Br2, Br,
Minus. Hmm.
Brf2 plus.
Hmm.
Option C, CiO2, comma Brf,
L. Chlorine.
ClO2, comma Brf. Option D,
Hmm.
C minus
Hmm.
O3.
Okay. So these are the options. Okay. What is isoelectronic species? Isoelectronic species. Tell me. What is isoelectronic species? Anyone? Adul, can you tell me? Switch on your videos.
Same number of electrons.
Yeah, atoms, molecules or ions which have same number of electrons. It is known as isoelectronic species. Isoelectronic species. All of you please switch on your videos. Okay, so isoelectronic species. Okay, so you have to select the pair from this isoelectronic pair from this option, isoelectronic pair. That means same number of electrons. Option A, ICl2. Option ICl2, ClO2. Option B, BrO2 minus, BrF2 plus. Option C, ClO2, BrF. Option D, Cn minus O3. So you have to find out the total number of electrons present on the atom. Then you have to add this total number of electrons. If there is any plus sign or minus sign, if there is plus sign, you have to subtract one electron from that. If there is plus charge, you have to add one more electron. Okay. If it is plus, you have to subtract one electron. If it is minus, you have to add one more electron. Clear? So here the correct answer is option B, BrO2 minus, BrF2 plus. So I will show the method of finding out the total number of electrons in BrO2 minus and BrF2 plus. Then the rest of the options you have to do it yourself. Okay. So it's, yeah.
Just a minute, ma'am, for writing.
Okay, okay.
Ma'am, the first option, like, is the C inside like modulus?
No, it's ICl. I for iodine. Then Cl chlorine. In chemistry, there is no modulus, right?
Okay.
Yeah. So have you completed this one?
Yes, yes, yes.
Okay, then we can just do that to find out the isoelectronic pair. So here the correct answer is BrO2 minus, then BrF2 plus, right? So what is the atomic number of bromine? Atomic number of bromine. Anyone? Atomic number of bromine. That is the total number of electron for bromine. right? Tell me. That is 35, okay? So 35, that's the total number of electron in bromine, plus, what about the atomic number of oxygen? Oxygen, atomic number. Tell me, children.
16.
Huh? 8 or 16? 8. But here there are 2 oxygen atoms, so 2 into 8. 16 is the atomic mass, okay? Then here there is 1 negative charge. So 1 more electron. This is the total number of electron in this BrO2 minus. 35 plus 2 into 8 plus 1. So 35 plus 16 plus 1. It is equal to 52, right? The next one is BrF2 plus. BrF2 plus. So bromine, again it is 35. What about fluorine? Atomic number of fluorine?
9.
9. So first you have to learn the first 30 elements in the periodic table. Okay. Their atomic number, symbol, name. Clear, children? So 35 plus 9 into 2. And there is 1 plus charge. So it will become minus 1, right? Minus 1. So 35 plus 9 into 2, 18. 18 minus 1, 70. That is also equal to 52, right? So this is the method to find out the total number of electrons. So here the number of electrons is same. So this is considered as isoelectronic pair. So to find out the number of electrons, atomic number, you should learn. Because atomic number and number of electron is same, right? So this is the method to find out the isoelectronic pair from the options. Clear, children?
Yes, ma'am.
Okay. Then again back to questions. Question number 90. Question number 90. Rijas, can you read the question? Switch on your videos. Yes.
The industrial preparation of SO2 is A. S plus O2 gives SO2. B. SO3 2 minus plus 2H plus gives H2O plus SO2. C. 4FeS2 plus 11O2 gives 2Fe2O3 plus 8SO2. D. All of the above.
Option D, all of the above. So which one is the industrial preparation of sulfur dioxide? Page number 193. Here you can see the different methods of preparation. From this options, you can tell me which is the industrial preparation of sulfur dioxide, SO2.
C.
Option C, right. What about option A? That is laboratory method, right? Actually, these two are laboratory methods. Then option C, that is the industrial preparation of sulfur dioxide. 4FeS2 plus 11O2 gives 2Fe2O3 plus 8SO2. Okay. Shall I move to next question?
One.
Okay. Okay. Then question number 20. Match the formulas of oxides given in column 1 with the type of oxide given in column 2 and mark the correct option. Okay. So here is one, match the following, and you have to identify the correct option. Okay. Column 1, Pb3O4, N2O, Mn2O7, Bi2O3. And in column 2, neutral oxide, acidic oxide, basic oxide, mixed oxide. So you have to identify among this different oxide, which one is neutral, which one is acidic, which one is basic, and which one is mixed. Yes. Oxides. It's in page number 190. Simple oxides are there. We have classified oxides into different types, right? Neutral, acidic, basic, mixed, amphoteric. I think mixed is not there in textbook, right? Neutral, acidic, basic, amphoteric, neutral. Page number 190. Just read the portion and tell me the correct answer.
Ma'am,
Hmm.
20th question, right?
Yeah, sure.
Ma'am, 20th question, right?
Yeah, 20th question. This one.
Because
Just to match the following. You are searching for the beginning of the question, right, Achu? Just match the following. That's it. Hmm.
Mix is there in the textbook.
Yeah, I found it. Yes, PB3O4, right? Okay. Then what about others? N2O, Mn2O7, Bi2O3. Not there in textbook. Neutral is there. The last part. Which one is neutral?
N2.
Yeah, N2O is neutral. Then Mn2O7, Bi2O3. We can search for the option with A, 4 and B1. A, 4, B1, right? So the correct option is option B. Okay, option B. And you can also add this example. For option C, it is 2. That means it is acidic oxide. So you can write this Mn2O7 for the example as acidic example for acidic oxide in your textbook. I think this example is not there in the textbook. Here the examples given SO2, Cl2O7, CO2, N2O5, right?
It is there in the textbook.
Where
page
here this one is page 190. Yeah, Gauri, can you tell me? Same page itself? Yeah, okay, Mn2O7. Okay. Then what about Bi2O3?
That is not there, I guess.
Okay. So Bi2O3, that is basic. So you can write the examples of basic Bi2O3 also. Na2O, CaO, BaO is given in the textbook. Along with that, you can write Bi2O3. So option B is the correct answer. Okay. Naureen, can you read the question number 21?
Structure of sulfur atom in SO2 molecule: AsP, BsP2, CsP3, DsP3d.
Okay. Structure of sulfur atom in SO2 molecule. Do you remember the structure of sulfur? sulfur dioxide, children? Structure of sulfur dioxide. It's in page number 194. Double bond is already there. So can you guess, children, which type of hybridization is there? sp or sp2 or sp3 or sp3d? Yes.
sp2.
Yeah, sp2 hybridization. Okay. Structure of sulfur atom in SO2 molecule, that is sp2 hybridization, because double bond is there. So it belongs to sp2 hybridization. Children, switch on your videos.
Ma'am, this point is not given in the textbook, right?
Sometimes they're in the textbook. Just wait. Yeah, hybridization is not mentioned in the textbook. But due to the presence of double bond, it is sp2 itself. Okay. Yeah, Gauri, you found out that?
No, ma'am.
Okay. Then question number 22. Punya, can you read the question?
The catalyst used in contact process for the production of sulfuric acid is Al2O3, Cr2O3, V2O5, MnO2.
Yes, it is the catalyst that is used in the contact process for the production of H2SO4. Which one? Al2O3, Cr2O3, V2O5, MnO2.
V2O5.
Yeah, V2O5, vanadium pentoxide. Option C, V2O5. Have you completed? Then the next question, that from group 70. An addition of concentrated H2SO4 to a chloride salt. Colorless fumes are evolved, but in case of iodide salt, violet fumes comes out. That we can discuss in the next session. Okay. So question number 24. Which of the following are peroxo acids of sulfur? Peroxo acids of sulfur. Do you remember the names or chemical formula of peroxo acids? Oxo acids of sulfur. Option A, H2SO5 and H2S2O8. Option B, H2SO5 and H2S2O7. Option C, H2S2O7 and H2S2O8. Option D, H2S2O6 and H2S2O7. Which is the correct answer? Sulfurous acid is there, sulfuric acid. These two are not peroxo acids. Okay.
C, right?
Which one? Which one? C. Okay. What about their names? H2S2O7 and H2S2O8.
I don't know.
Yeah, that's in page number 194. peroxo disulfuric acid, then pyrosulfuric acid. This H2S2O7, that is oleum, right? You know the name of H2S2O7, that is oleum. That's in the preparation of sulfuric acid. H2S2O7. It's a UPSC name, that is pyrosulfuric acid. Common name is oleum. Okay. Then question number 25. From following, which pair of element kept in same group? Okay. Option A, elements whose atomic numbers are 17 and 38. Elements whose atomic numbers are 20 and 40. Elements whose atomic numbers are 11 and 33. Elements whose atomic numbers are 17 and 35. In group 16, which are the, actually it's from the next part. But you know the answer. Which are the elements present in the same group with atomic numbers? What is atomic number 17?
Chlorine.
Yeah, it's chlorine, right? Then I just mentioned about the atomic number of bromine. What is that? Bromine.
35.
35. So these two belong to same group, right? So option D, elements whose atomic numbers are 17 and 35. And 35. So have you completed this question, children? Shall I move to next one?
No, ma'am.
No. Okay. Then the next section, that is assertion reasoning. Okay. Just wait. Okay. So here the assertion and reason is given. Assertion, both rhombic and monoclinic sulfur exist as S8, but oxygen exists as O2. The reason here, oxygen forms p-pi multiple bond due to small size and small bond length, but p-pi bonding is not possible in sulfur. So first one is the assertion and reason. So you can tell me, is it correct or not? Emmanuel, oxide is simply oxide, right? Oxo acid, that is acidic in nature, along with oxygen is there. Clear?
No, ma'am.
Yeah. Oxide means when a metal or element reacts with oxygen, it will be oxide. Okay. Then oxo acid means that is acidic in nature and oxygen is already present there along with hydrogen. Clear?
Okay, ma'am.
Yes. So assertion both rhombic and monoclinic sulfur exist as SH, but oxygen exists as O2. And the reason oxygen forms p-pi multiple bond due to small size and small bond length, but p-pi bonding is not possible in sulfur. This is correct, children. Assertion and reasoning. Do you remember the common options A, B, C, and D that you already written in the previous day? Can you tell me? What about the assertion and reason? Is this correct? Here the assertion and reason is correct. So it is option A. Option A means both assertion and reason are correct. Statements and the reason is the correct explanation of assertion. Okay. Option A. That is the correct answer. Because we know that oxygen that's in the second period, they do not have d orbital. So they will form O2. They can exist as O2 molecule. D orbital is absent. In the case of sulfur, that's in third period, it has d orbital. So p-pi d-pi bonding is possible. Then I will send you the remaining questions. Just look at question number 47. Assertion, oxygen has a covalency of 4. Reason, d orbitals are absent in oxygen. This is correct, children. Assertion, oxygen has a covalency of 4. Here also this assertion and reason is correct. D orbitals are absent in oxygen. So only p bonds, p orbitals are there. So the maximum covalency of oxygen is also 4. So here also the correct option is A. Then we can discuss the remaining question in the next class. Okay. For the next week, I think there will be next class on Tuesday or Thursday. Sometimes Tuesday will be holiday. That will be informed in the group. I don't know. Okay. So you have to learn group 17 and group 18 for the next week. We can practice the questions and there will be one unit test based on this chapter on Friday evening. Okay. Friday evening. Next Friday evening. There will be 1 week time. So you have to practice maximum questions. Then learn this chapter thoroughly. Okay. Clear, children?
Yes,
Okay.
ma'am.
Then we can discuss the remaining question in the next class. Now it's time to wind up. So thank you all. See you in the next class. Bye.
Thank you, ma'am.